Hello and welcome to another episode of Invalid Entry. My name's James Taylor and today we are going to be talking about libraries in computers. Not libraries where you go get your books from, but they are basically bits of code that you can call as opposed to executables or scripts, which are bits of code which you run and actually do something out the box, or commands that you run. The idea behind libraries is you write libraries yourself. You may write libraries inside of an application, but usually they're independent things which are imported into your code. Maybe they're third party, maybe they're common across more than one application. You import them in. Different languages, different platforms do it differently. So there's a big difference between static and dynamic libraries, for instance. There's a difference between how different languages import and execute libraries, how they refresh what libraries are available. There's also a difference between some languages between imports and includes, about how those libraries are actually technically imported into code, which can have a difference on the code size and the execution speed and so on. The worst language I ever wrote in was a language called Not Quite C, which was nothing like C. That language, the import actually literally pasted the block of code, the other file you're importing, directly in. So you could import, snippets of code, and it would actually make your file super big. It was truly terrible as a language. Back 20 years ago, we were writing it for these devices. So be aware that this is generic, this conversation, but different languages do it differently. Libraries should have a purpose. So if you're importing a library, if the library gets bigger and bigger, then generally those libraries may actually become frameworks or tools or entire applications in their own right. So if you're thinking something like Unreal Engine is a library, Unreal Engine is more of a collection of libraries you're importing as a framework rather than one single library. So there's a bit of a grey area as to what a library is, but library should have a purpose, like it does a thing. You do find some generic tool libraries, and they can be very handy, but usually have a theme around them, such as their console decorator libraries. The point of libraries is this. Now, I had this conversation about, he doesn't like using libraries to understand and solve the underlying problem. Well, the language you're writing comes with built-in libraries, so you're always using libraries of some kind unless you're writing raw assembler. And the idea behind libraries is it allows you to concentrate your time and effort on things that you are trying to solve. So if I'm trying to write an anti-cheater detection system for Minecraft, I concentrate on that. I don't have to worry about, for example, how I transfer files from the server to my local system. I just say, I'll use an SFTP library. I don't have to start worrying about opening sockets and doing firewalls and timeouts and protocols. I just say, go get me those files. So it simplifies those tasks, those functional tasks, and lets me work on the business logic of the problem I'm trying to solve. And that's true if I'm working at home on a home coding project, to if I'm working professionally. However, there are good libraries and there are bad libraries. And what counts as a good library does depend on your situation, about whether you're doing a bit of amateur home programming or whether you're doing some professional engineering work. But I break it down to these topics: maintainability, compatibility, bloat, dependencies, and license. License, I'll go first. It's good to make sure that you respect the library's license, so that may change what you're doing. If you're distributing binaries, such as an application, a mobile application, that may have an impact on what you're doing. I'm a big open source person. I like open source. I give stuff to open source, but also I get paid to write things at work as well. So I have to respect that. If I want people to respect my professional code and the license I put on it, or the license my company puts on it, then I have to respect those open source licenses as well. So maintainability, how well is the library maintained? Is it being updated? Is there a community of people behind it? Are there people I can go to ask for help on how to use this? Compatibility is more about, is this library working the same way I want my code to work? You may have libraries out there which do what you want to do, but they work very differently, or they have loads of complexity to them that you don't necessarily want. And that may shift which library you choose. And that's why you may find multiple libraries that solve the same underlying problem. Bloat is about how big the library is. I'll give a demo of that. Perhaps you want to do a little bit of cryptography and you want to very specifically use AES, for example. So you may want an AES library. You might not want to import all of OpenSSL, which has every single crypto library ever invented by man, basically, just to do a little bit of encryption. So bloat matters because that can scale your application one way or another. Adding in extra dependencies and bloat there can also introduce security risks and security vulnerability you didn't want. Dependencies, looking at what that library also depends on, introduces a lot more sub-libraries. So if a very big library, it may have loads of little libraries it's bringing in, and they also may have some problems that you don't necessarily want to import, and therefore licenses on it. There's a library we use at work, and we had it misconfigured, so it was importing Tox. Tox is the test tool, shouldn't have been in the dependency of that library. but it is, and that's an issue. So very quickly, here are a couple of example libraries. Request is a Python library, really big Python library. And when I look at it saying, is this a good library for me? It's been around for a few years. The oldest line I can see straight here is 4 years ago. I can also see it's got 1.1 million users. And that's really important because it means there's a big community of people out there who know how to use the library. It's got nearly 600 contributors, which means there's a lot of people who help develop it. It means it's well maintained. If I sort of look at the turnover of issues, there's a lot of issues open, which sometimes can be bad, but these issues are all being closed off. They're all relatively recent. There are a few going back to late last year, but generally speaking, they're closing off issues. I look at closed issues. 3,000 closed issues means this library is being used. Their maintainers are responding to the queries and so on. On the other hand, you have a library like this. This is a little personal library. It's only got 3 contributors. In fact, one is a robot, so it's only got 2 contributors. And it hasn't really got a long heritage here. It's got 82 commits over 15 months. This one had like 6,000 commits. So this is perhaps one to be a little bit more wary about. It's also written in Chinese, which, nothing against Chinese programmers, but I won't necessarily understand the comments. And you also start looking at the issues. There's no issue tracking here whatsoever, which suggests people are not using this library as a library. Maybe this isn't one to base your multi-million-pound business on. Okay, and like requests, a lot of support. This one, maybe it's a bit more experimental, a bit more fun. Talk about OpenSSL. This OpenSSL is a very big library. You see straight away the number of folders it has, the number of files in here. It's very well documented. It's a very important library to the infrastructure, the whole world, to be honest with you, because OpenSSL is used by Linux. I think it's used by Windows as well. A lot of programs use OpenSSL to communicate with other services. It is the underlying part of the system, as opposed to Tiny AES. Tiny AES is a tiny C library which just does AES. In fact, the maintainer, people keep coming saying, can we add this to the library? And he says no, because it's a simple, small library specifically for putting on embedded devices. I've used this on an Arduino. That's where you really compress the size. I don't want to import everything. I don't want to rip a library out of OpenSSL. So there's a use case where these things work. Again, 18 contributors over a few years, 268 commits, not a massive library, but this one has more maintainability. And if you also look at the issues, he's actively, even though there hasn't been a commit in or a release in like several months, he's actively looking at tickets and coming back with comments. The people put comments that he's coming back and closing some of these tickets. So yeah, that's a brief overview of how I look at library. When I have a library, I go, do I want to have this library in my source code? I'm importing random code from the internet onto my computer. I'm going to execute it, but sometimes inside of a secure space. So I'm very critical of whether this library is a good or bad library. And hopefully with this, you'll be able to detect good and bad libraries and make some decisions of your own.